Hello everyone, this video is about interfacing the PIC microcontroller, particularly the PIC18F458 with LEDs, relays and buzzer using digital switches. So let me quickly guide you through the procedure of this project. So our first step is to open the MPLAB IDE software, then go to project, save this file to desired project location. In my case, I've already created a folder, so I'll save it there. Make sure that in View tab these project window and output window are checked as we need them to add our source. Now once the project is saved, open the project wizard and check that we have selected the C compiler. Don't forget to select this device PIC18F458 since we'll be working with it, and click on next. Since we have already created the project file, no need to create a new project file. Simply reconfigure as active project and select make changes without saving. Click on next, and then finish. Now create a new file wherein we will be typing our C code. Now save this file in the same folder where you have created your project. And just don't forget to give the extension .c. Make sure to add this C file in this source file folder. Now after adding this source file, build this project. If the message build succeeded appears, this means that our hex file required for the microcontroller in Proteus has been generated, and we can always check this hex file in our project directory. Now as you can see in my folder, this hex file has been generated, which we will be needing to program the microcontroller in Proteus. So our next step is to open Proteus and build the simulation circuit. Now create a new project. Now click on next. Select create a schematic from selected template. Select default. Next. Do not create a PCB layout, and it's a no firmware project. So next and then finish. Now, since I have already created this project, if you are supposed to build this circuit from the scratch, simply gather all the components required to build it, such as the capacitors, the crystal oscillator clocked at 4 megahertz. Select the capacitor, set their capacitance to 33 picofarad as shown here, and you can you can easily find all these components in Proteus component library here. Just search all the keywords such as PIC18F58. Yeah, this is the microcontroller we have used. And then for the capacitor, simply normal capacitor we have used. Then for the digital switch, to find it in the Proteus library, you need to type in the state. Yeah, make sure to provide adequate DC supply to these pins of the relay, the lamp, and the first pin of the microcontroller. You can find this DC signal here in the generator mode tab of Proteus. Yeah. Now just make sure to connect all the components carefully according to their pins. Refer to the schematic diagram provided in the description. Now once you have created this circuit, we need to add the hex file which is generated in the project directory of MPLAB software. So double click on this microcontroller, select this. Yeah, so this is the hex file which will need to program this microcontroller. Open, click OK. Now run the software, run the simulation. So as you can see here, when I toggle the switch connected to the relay, the lamp or LED turns on and off correspondingly. When the switch is off, the negative terminal of the lamp is not connected to the ground. So the circuit remains open and the lamp stays off. And once the switch is turned on, the relay energizes, connecting the lamp's negative terminal to the ground, thus completing the circuit and turning the lamp on. And here other two pins are configured for these two LEDs. So this pin number 1 is corresponds to this LED, and this third pin is associated with this LED. Note that in our current C code, the program is designed for one switch at a time. So if you want to operate multiple switches simultaneously, so we need to modify the code accordingly. For example, by adding conditions for multiple bits and updating the port states. So yeah, that's it for this project. Now, moving on to the next experiment, which is also the part of our SPPU syllabus. We have to interface an LCD with PIC microcontroller. So for this experiment as well, we'll also need to follow the exact same steps as we did in this one. The only difference is will be the C code and the Proteus circuit diagram for your LCD interfacing. So we'll need a new C program for LCD interfacing in MPLAB IDE, and in Proteus will will connect the LCD module to the microcontroller pins accordingly. So as you can observe, I have already created this project. I just need to build it. So the respective hex file will be created in the project directory where you will save this project, and that hex file you will need to generate in the Proteus circuit you will create. So this is an easy schematic. So just connect all the all the pins of microcontroller and LCD with each other carefully. Uh, Give crystal to the microcontroller, the capacitors, and that's it. The DC signal for VDD pin of LCD and the first pin of the microcontroller. So same process again, just double click on the microcontroller and select the hex file to program the microcontroller. Click on OK, run. Yep. You can also change this data being displayed on the LCD by making changes in the code. For example, now instead of sending the data character wise, we can always use array to send it efficiently. Now, once you have done editing the code, just simply save this code, Control S, and don't forget to build this again so that the hex file which was generated earlier will get updated. Now, unlike 8051, we are not supposed to redump the hex file on this microcontroller. We just need to pause this and rerun the simulation, and the data which we wanted to, and the new data will be displayed on this LCD. So I have provided the C code for LCD interfacing and Proteus schematic diagram in the video description, so you can easily refer them. As I mentioned earlier, I have also added the Proteus project file with the complete circuit in the Google Drive link. However, it's possible that you might not be able to open the project file directly on your own computer, because this usually happens if Proteus version differs from mine. Because of version differences, the project file or circuit may not open properly. So the best approach is to build your own circuit in Proteus and dump the hex file generated from the MPLAB IDE into your microcontroller. To make this easier, I have also attached the image of circuit diagram in the respective folder in the Google Drive link, so you can easily refer them. So that's it. I think we have successfully completed both the experiments, the LED and relay interfacing and the LCD interfacing with PIC18F microcontroller. I hope this video helps you understand the complete project flow, including the circuit building, code writing, hex file generation, and simulation in Proteus. Thank you.